For number 1, the amplitude is 3, and the period will be 2 pi divided by 4/3, which is equal to 2 pi over 1 times, remember the reciprocal when you're dividing by a fraction will be reciprocal of 3 over 4, which gives you 6 pi over 4, which reduces to 3 pi over 2. All right, so I know for sine, it starts at 0 and it's going to end at 3 pi over 2. In order for you to find the next intercept, you need to find where is it in the middle between 0 and 3 pi over 2. So what you do, 0 plus 3 pi over 2. So it's 3 pi over 2 divided by 2. You're always dividing by 2. So in this case, it's 3 pi over 2 times 1 over 2. So it's 3 pi over. So what I'm going to do is I'm going to start counting by quarters. So this is going to be pi over 4. The next one is 2 pi over 4, which reduces to pi over 2. The next one is 3 pi over 4. The next value would be 4 pi over 4, which reduces to pi. So the next one is 5 pi over 4. And the next one is 6 pi over 4, which reduces to 3 pi over 2. So I know sine starts at 0, and I know now the middle between 0 and 3 pi over 2 is 3 pi over 4, which is right here. This is where it's going to get a little bit more trickier. So now I need to find the middle between 0, the middle point between 0 and 3 pi over 4. So once again, I'm going to add, and I'll use a different color, I'm going to add 0 plus 3 pi over 4 and then divide by 2. So what you notice, you get 3 pi over 4 divided by 2, which comes up to 3 pi over 8. So now I got to count by 8 to get in between 0 and 3 pi over 4. So how do I get to 8? This is going to be pi over 8. The next one is 2 pi over 8, which reduces to pi over 4. And so the next one is 3 pi over 8. Well, guess what? That is our max, and it's going to go up 3 units. 3 pi over 8. The next one is 4 pi over 8. This is 5 pi over 8. And the next one is 6 pi over 8. This is 7 pi over 8. And this is 8 pi over 8. And this right here is going to be 9 pi over 8. So to find between 3 pi over 2 and 3 pi over 4, I need to add those two. So what I'm going to do is I'm going to go ahead and erase some of this here so I can show you the work. So now I'm going to get the value that's between 3 pi over 4 and 3 pi over 2, and I'm adding fractions. I have 3 pi over 4 plus, I want a common denominator. I want it to be 4. So you have 3 pi over 2 multiplied times 2. So you get 3 pi over 4 plus 6 pi over 4. So when you add those two, it's 9 pi over 4 divided by 2. So you get 9 pi over 8. And that's in between 3 pi over 4 and 3 pi over 2. So that's going to be our min, which is at -3. And here is our graph. Okay, so if you want to check with Desmos, what you do is you go to desmos.com and you're going to type in y equals 3 sine. In this case, it's going to be 4/3 So let me go ahead and do this again. Y equals 3 sine 4/4 x. So we have 3 times the sine of 4/3 x. And if I look at my table, we started at 0. And then we had a maximum point at pi over 4. Nope, it was at 3 pi over 8. That was our maximum point. It's up here. 3 pi over 8, which that's what we had. And then we have the intersection, which is at 3 pi divided by 4. That's the next intersection. So here's the first. Here's a max, 3 pi over 8, comma 3, our intersection. And then, of course, we intersect at 3 pi over 4. The next one is 9 pi divided by 8. And that's -3. That's our lowest. And once again, we end at 3 pi divided by 2. And there's our cycle. 0, 0, 3 pi over 8, 3, 3 pi over 4, 0, 9 pi over 8, -3, and then we come back to our the end of the cycle, 3 pi over 2. And that's what we have. For number 2, we're asked to graph y equals 9/2 cosine of theta. We know that the amplitude is 9/2, so it's 9/2. We know that cosine has a period of 2 pi. It's understood that cosine has a period of 2 pi. So if we go to our graph, we know that at 0, it's going to have a max at 4.5. And we also know at 2 pi, it's going to have a max at 4.5. In between 0 and 2 pi is pi. We know at pi it's going to have a min at -4.5. And in between 0 and pi is pi over 2. And in between pi and 2 pi is 3 pi over 2. And so here is our graph. Now if you want to check this in Desmos, this point is 0, 4.5. This is pi over 2, 0. This is pi, -4.5. This is 3 pi over 2, 0. And this is 2 pi, -4.5. So if we go over here to Desmos, and we type this in and we say 9 divided by 2, and then we have cosine of x, and we start at 0, and we know we're going to end at 2 pi, which is 4.5, and we know that it's going to have a minimum. It's going to have a minimum at pi, and we know it's going to intersect at pi divided by 2, and we also know it's going to intersect also at 3 pi divided by 2. So there are our points, and you notice they're exactly as our handout, what we got in our handout, and it repeats. For number 3, the amplitude is 2, which you're going to notice is very negligible. We don't have to worry about that. The period we know is shorter than sine and cosine. It's pi over b. In this case, it's going to be pi over 2. So the period has to be done by pi over 2. What you got to find is the left asymptote, which is going to be 2 theta equals negative pi over 2. Divide by 2. Divide by 2. So we know that theta is going to be negative pi over 4. That's the first asymptote, the left one. To find the right one, it's going to be 2 theta equals pi over 2 divided by 2. Why do I use negative pi over 2 and pi over 2? These are the parent asymptotes. So I'm using the parent asymptotes. Just so you know, I'm using the parent asymptotes. So I divide by 2. So theta is going to be pi over 4. Okay, and I'm going to make this larger so you can see it. So the amplitude is going to be very negligible. It's 2. We know that the period will be pi over 2. And we know that the left asymptote is going to be at negative pi over 4, as I just explained to you. And the right one is going to be pi over 4. So let me go ahead. So pi over 4 is in between 0 and pi over 2. So this right here is your pi over 4. This is your right asymptote. And then your left asymptote is right here, right in between 0 and negative pi over 2. And just like I told you that the amplitude is going to be negligible, so you just have to do this graph like this. And what's going to happen is this is going to repeat every pi over 2. It's going to repeat. For example, we have here pi over 4, so the next asymptote will be right here. 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 It's actually every pi over 4 multiples of pi over 4. So it's going to be like this, and I'm drawing it in red so you can see that it's going to repeat. And of course I didn't go in the left direction, but it does also repeat on the left side. Okay. For number 1, the amplitude will be 1/2. Actually, it's the absolute value 1/2. The period, we have to go back and we have to write the reciprocal. So to find the period, I'm going to find, it's not secant. Let me fix this, it's not secant. Actually, the reciprocal for cosecant is sine. So to find the period, it's 2 pi over whatever this is. In this case, it's 2. So the period will be pi. So what I'm going to do, in order for me to sketch cosecant, I have to draw sine, sketch sine, and then from sketching sine, I can identify the asymptotes, and I can also identify the cosecant graph. So I'm going to go ahead and make this larger. And I know that for sine, it's going to start here, and for this particular period, it's going to end at pi. So in between 0 and pi will be pi over 4, and pi over 2. In between 0 and pi over 2 will be pi over 4. So in this case, it's going to go up 1/2. And in between pi over 2 and pi is, so this is 3 pi over 4. So it's going to have a point right there. So this is pi over 4 and this is 3 pi over 4. And so I'm going to go ahead and sketch that. And if you want to extend it, you can. Wherever it intersects the x-axis, that's going to be my asymptote. So the asymptote is going to go through 0. It's going to go through pi over 2. And then it's going to go through pi. And what's going to happen, it's going to repeat. So now it's going to go through 3 pi over 2 and 2 pi. So now to draw cosecant, it's going to be parabolas. parabolas, okay? For number 2, the amplitude will be 2. And to find the period will be 2 pi divided by 8 over 3. In this case, it's 2 pi times 3 over 8, which comes out to be 6 pi over 8. As you can simplify, it's going to be 3 pi over 4. Know that it's going to go 0, pi over 4, 2 pi over 4, 3 pi over 4. So 0 plus 3 pi over 4 to find the middle. So we have 0 plus 3 pi over 4, and then you're going to divide by 2. So it's going to be 3 pi over 8. So I have to break this into eighths. Here's an eighth, here's an eighth, here's an eighth. So at 3 pi over 8, I'm going to have, at 3 pi over 8, I'm going to have a minimum of 2. At 0, I have a max at negative 2. And then at 3 pi over 4, I have a max of 2. So in between 0 and 3 pi over 4, and this is going to be, this right here is 3 pi over 8. So now I'm just going to sketch. And so I'm sketching that. Now the amplitude will occur in between 0 and 3 pi over 8. So I'm going to go ahead and graph the amplitude. Graph the asymptote. And then the other asymptote occurs in between 3 pi over 8 and 3 pi over 2. And let me just draw. Here's a part of it. Here's another part of it. And then here's a part of it. So if you want to know where the asymptote is, I have to get half of 3/8. So half of 3/8 is going to give you 3/16. So your amplitude happens at 3/16. This amplitude, 3 pi over 16. And the other amplitude is between pi over 2 and 3 pi over 4. Add 3 pi over 8 plus 3 pi over 4 times 2 times 2. So it's 8. 3 is 9 pi over 8 divided by 2, which is 9 pi over 16. So this will be 9 pi over 16. Now, if you want to verify my work, we can verify. So I know that the period is from 0 to 3 pi over 4. In between 0 and 3 pi over 4 is 3 pi over 8. The asymptotes, all I did is I got the half between 0 and 3 pi over 8, which is 3/16. And 3 pi over 8 plus 3 pi over 4 divided by 2, that's the in-between part. It's going to be 9 pi over 16. So if I go to decimals, I'm going to go ahead and write 2 times the secant 3/8 x and actually it's 8/3. And remember, we had a period of from 0, and this is 3 pi divided by 4. It's 2. That's right, it's at 2. And then the next, which is the asymptote, 9 pi divided by 16 should be undefined, that's right. And then the next one was the in-between, which is 3 pi over 8. 3 pi divided by 8, that's -2. And then over here would be the asymptote, 3 pi divided by 16, and there's undefined. So if you wanted to draw your undefined lines, x equals 3 pi divided by 16. There's the first one. The next one is x equals 9 pi divided by 16. And there's the other asymptote. And that looks exactly like my graph. Okay. The amplitude is 1 over 4. The period is pi divided by 1/3, which will be the reciprocal of 1 over 3, which is going to be pi times 3 over 1, which is 3 pi. We know that the left asymptote is going to be determined by 1/3 theta equals 0. We know that the left asymptote will be 0 for the parent function, so therefore theta is equal to 0. The right asymptote is 1/3 theta equals pi, so theta will equal to 3 times pi, which gives you 3 pi. So our asymptote starts at 0 and ends at 3 pi, so it's somewhere over here. And since this is cotangent, in between 0 and 3 pi, we got to find the middle. So 0 plus 3 pi divided by 2. So the middle will be 3 pi over 2. That's where it's going to be 0. And then cotangent behaves like this. So I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So you can kind of estimate the asymptote is right here.